In this video, we take a look at strategies for designing and engineering a realistic hinge. Why do we do this? Well, hinges are important anytime there is a door or opening that needs to operate. Let's review the basic parts of a simple hinge to better understand what they do. Now, this first example assumes the door and case are both flat. We'll do a more complicated example next. On the right side, we've got the two basic leaves, which also continue to form into these knuckles, which are connected. And then there's a pin down the center. The entire assembly of the center section is called a barrel. And if you look on the left, we typically will have something fixed and then the door part that swings. The important thing to understand here is all rotation occurs around this straight axis. You cannot have it curved. And typically we have one part that stays still, which is the fixed part of the cabinet, or in our example, the spaceship, and then the canopy or door that moves around that. In our next example, which you hopefully recognize, we have a variation. So the knuckle stays the same with the axis and pin down the center, but the leaves can actually break apart into different areas. Notice on the diagram top view, we have these two little extenders off to the left. I'll point these out here. And then on the rounded door, we have an extender there. So they don't have to match both sides. So this is important to understand that when we have curving doors or even more complicated fixed parts like our spaceship, that you maintain this barrel and center pin on a straight axis. Anything else can vary. So jumping ahead to our final solution, the hull is on the left, the glass canopy is on the right, and notice there's the barrel and pin going down the center with that perfectly linear axis, and the extension arms, or leaves in this case, don't have to perfectly line up. They basically hit whatever they need to. And you can see what happens here on the side view. That barrel and pin is all perfectly linear. So let's go ahead and build our crazy complicated hinge, but along the way you'll see how it's actually not that hard. So I've got all the curves drawn here. Probably the most important thing you can do first is to draw an axis line. We're going to be moving and building geometry and mirroring. So the pivot line is important, as is kind of another center line going down the other way for any mirror operations. Another cool trick I'm doing here is I've got the pin in the center. So let's go ahead and just extrude that with a solid command. Now I'm going to use the both sides, and the cool part here is I can just snap to this geometry over there. Double check your O-snaps. I've got end and point down the lower left. And then another cool little trick here is we can do revolves without having the geometry touch the axis. So we'll go to the surface. I've got the line selected there, and we'll go to revolve. And now you can see the importance of having this axis line here. I can use my O-snaps to pick both ends. And then instead of typing in the beginning and ending, we can just say full circle there on the command line option. And so there you have it. There's our pin down the metal. There is the barrel assembly. You will notice that it's one single piece. Let's go ahead and just do another little quick hack. I'm going to select these two curves here, and we'll just do a Boolean split or difference to chop these into the different parts you saw earlier. Go ahead with solid, extrude planar curve, straight. One thing to watch out when you're doing this, in any operation, I always make it bigger than needed. And the reason I do that is occasionally if something is really close, you may just miss it. So I even risk it, just go way past like we have here. So we can go to the Solid Tools toolbar up here. I'm going to select Boolean difference. So we always want to pick the part we want to keep first. That's the barrel. Right click, and then the two parts that we subtract with, those planes we just made, right click. So that's a great way to make different parts, have the overall shape be kind of interesting and clean, and then just slice and dice it as a secondary operation. Okay, let's work on the extenders. Again, I've already drawn these earlier, and I've tried to have the geometry overlap internally. We don't see that, so it's not an issue. And then the same thing with, we're going well past anything we want to intersect. We can always trim it back later. Also notice these curves are drawn on the center, so I'm keeping things organized. Let's do another solid extrude planar curve straight. Now, if you go both sides and you want to type in a number, remember that number is going to be doubled. I want this to go 8, so I'm going to type in 4, and it just now went out 4 in each direction for a total of 8. So that's the extender for the glass canopy. I've got another shape here. We'll use that, and we'll use this line as an extender for the hull part of the ship. Now to repeat the command, you can go up here in the command line and just right-click. And there was the last 10 or 15 things we've done. So that's a great way to jump around if you're just doing the same couple of commands. This is a great shortcut to find things that were fairly recent. Okay, so this one, I've actually moved that curve around a little bit. We're going to have this be about half as much, so 2 each direction. And then finally, since it's symmetrical, we can just select this and use the mirror command, which is why I've got this other axis line here. Now, the axis line is a little bit hidden inside, so if that happens, not a big deal. We can just switch over to wireframe. Anytime your geometry is getting a little bit too complicated or things are difficult to pick, go find the mirror command under Transform Mirror. So there is the geometry just created. I want to make sure I get the poly surface. Right-click, and the start of the mirror plane will be that axis we just mentioned. And I'll go back to Shaded View, which you can access here. There's also shortcuts available. I'll talk about those later. So there is your hinge. For further practice, I would continue trimming back the parts that go through the glass and the hull here. We're not going to do that. Instead, I'll wrap it up by saying the design of functional looking hinges makes any design more realistic, even if it's not 100% engineered. If you want to verify your hinge works, you can then do some rotation testing, which we will cover in a following video.